Look at how Pac-Man is moving below. Can you describe how Pac-Man moves? Take a second and think of an answer to this question. You might say Pac-Man is moving across the screen. Or you might say Pac-Man slides back and forth. Right? There's actually some math vocabulary here that we can use to describe the movement of Pac-Man. And so, we're going to have a word of the day. And I'm going to do the chant. Word of the day. Word of the day. So you can take out a sheet of paper and write down this word of the day. And the word of the day is translation. This is a math word that we can use to describe how Pac-Man was moving. You might have heard the word translation in other contexts. We're going to talk about what it means in math. So here's the definition for translation, and this is what you can write down. So a translation is a transformation where an object slides. Now, there's actually another kind of mathy word in this definition, and that's transformation. Transformation just means how we might change an object, like sliding it across the screen, like how we saw Pac-Man move. Notice with slides, I underlined SL, and there's an SL in translation. That's just a trick in terms of how you remember the definition for a translation. So we're going to be talking about sliding an object, just like how Pac-Man was moving on that screen. So I'm going to change screens here, and I'm going to show you an example of what this might look like in a problem. Okay, here's an example of a translation. So it says plot the image of point P under a translation by 3 units right and 4 units down. Here's point P. Before we begin, I'm actually going to record the coordinate of this point. So we are starting at -2, 1. This is my xy value. All right, we're going to translate 3 units right and 4 units down. I always like to underline that. This is what I'm going to need to do to point P. So, as I said, a translation is like sliding the point across. Think of that Pac-Man that we saw. And so we're going to slide it 3 units right. So we're going 1, 2, 3. And then we're going to go 4 units down from here. 1, 2, 3, 4. So this is the point that we're going to end up. Here's how I'm going to label this. So we just translated point P. And whenever we move a point on a graph like this, I'm not going to label it just point P because that would be confusing. I would have 2 different point P's. What we do is we put an apostrophe by that point P. And this marks that. It's kind of like a mark showing like, hey, this is a point P that we moved. We put an apostrophe on it. We actually call this P prime. And the coordinate of my P prime here is going to be 1, -3. So that is my new x and y value that we got from doing this translation. So this is an example of a translation. I'm actually going to go back to that Pac-Man that we were going to look at, and we're going to get into some characteristics about translations. So here we see Pac-Man again, and it says, how would you move Pac-Man to get the strawberry? If anyone's ever played Pac-Man, you know if you get the strawberry, you get more points. So Pac-Man's starting at this green dot here, that's -1, -2, and we're going to adjust these sliders in order for Pac-Man to get the strawberry. Keep in mind, we can't move past any of these blue boundary walls. So, how are we going to do this? Well, it looks like I'm going to use translations. I'm going to translate him to the right. In terms of how much I'm going to translate him, it looks like I'm going to go 1, 2, 3. And then I'm going to translate him up. In terms of how far up I'm going to go, it looks like I'm going to go 1, 2, 3, 4. Oh, and in this case, it looks like the strawberry got Pac-Man. All right, so he started at this green dot, and ended where the strawberry was at 2, 2. In this translation that we just did, where we went right 4 and then up 1, 2, 3, 4 as well. Oh, I'm sorry, we went right 3 and then up 4. The question I have is, how does that change the coordinate? We went from -1, -2 to 2, 2. And we did that by going right 3 and up 4. So how do these values change my x and y value? Take a second and think of that question. Maybe even look at the example from before. Where was our starting point? Where was our end point? And think, how does this translation change my x and y value? If you want to pause the video, see if you can come up with an answer, you can do that. And then we're going to write down this as a characteristic. Okay, so here's a characteristic of a translation. When we move an object right, like how we did with Pac-Man, you're adding to the x value. When you move it left, you're subtracting from the x value. If you go up, like we did with Pac-Man, you're adding to the y value. And if you go down, you're subtracting from the y value. This is a key characteristic of a translation. And instead of doing a non-example, like we sometimes do with the word of the day, I'm actually going to do an additional example using this characteristic. So I'm going to change my screen here. Okay, here it says plot the image of point Q under the translation. And this is something like this, where we have x, y, arrow, x minus 4, y plus 5. What this arrow means is that with this point, x, y, we're doing a translation that they describe here, right? So let's break this down. First, I'm going to look at point Q here, right? I'm going to write the coordinate for this point here. So we got 1, -2. This is my x and y value, right? So these are like instructions for our translation. What this is saying is that for my x value of 1, I'm going to subtract 4. And for my y value of -2, I'm going to add 5. So we end up getting a -3, +3. -2 plus 5 is +3, right? So I'm going to plot this point, -3, +3, right here. This is point Q after this translation. And remember, when we draw this new point, instead of having 2 different Q's, that could be confusing, we put this apostrophe by the Q, right? And we call that Q prime. So Q prime is here, -3, 3. We got that by doing the subtraction and addition that they say here with our x and y values. In the last example, we had counted, and you can still count here. Remember, when you're subtracting from the x value, that means you're going to the left 4 units here. And when you're adding to the y value, that means you're going up 5 units. So the subtraction and addition that we did is the same as counting on our coordinate plane here. So this is different from the last example, and you might see some problems like this. Thanks for watching.